pressure looks good.
Following up. Roger, roll, Atlantic. Flight downside, speed off.
Yikes. You bet. Okay. We don't need any more of these.
Good afternoon, everybody, and welcome to this week's episode of NASA Spaceflight Live, our weekly news show. Thank you so much for joining us. My name is Thomas Burghardt. I'm an editor and reporter for NASA Spaceflight, and I'm joined by two familiar faces to the show. First, on my right, I guessed right, Chris Gebhardt, assistant managing editor of NASA Spaceflight. Chris, thanks for joining me today.
My pleasure as always, Thomas. Good to be here.
Awesome. And then on my left, we have our resident orange rocket expert, Mr. Philip Sloss. Philip, how are you doing?
Good. How are you guys doing?
Always good. So we've got two people on to join us today. We've also got Michael Baylor in the background. You may hear him chime in a little bit, but we're here to discuss this week in space news, as always, and answer any questions. If you have questions about whatever we may be talking about in chat, please go ahead and tag us at NASA Spaceflight, and we'll bring those into a queue. We're going to try and answer a bunch of those during the show. It is a live and interactive show, as always, and but we're going to try and overview some of the recent news coming up, and also preview a big test that's coming up next week. You may have figured out based on the title and our guest Philip Sloss making sure he was on the show this week. So let's talk a little bit about that first and foremost, because SLS Green Run Hot Fire number 2 coming up next week. Well, I think we're going to start talking about that a little bit. So Philip, why don't you give us an overview on why we're redoing this test, what happened with the first one? Give us an update on our SLS status.
Okay, great. Well, let's start with something that happened yesterday is we got this resource reel from NASA, and this is we've been asking for this, and it took them 2 months this time, and hopefully they're promising this is going to turn around in a couple 3 days after they repeat the test. So fingers crossed there. But what's interesting about it is it's the first time we really got to see the whole test sequence, and especially the shutdown sequence, which we didn't see live. So this is the first look that we got. And so this is one of the cameras on the basically sitting between the engine section level and the service platform level here. And this is this basically lets you see what you're looking at here are the engine in the most foreground here is engine 1, and then if you go kind of clockwise around, so the left engine is engine 2, the engine in the far back is engine 3, and then the engine on the far right is engine 4. And if you look up above engine 4 there, you start to see some flashing. A little fire broke out in the engine blankets above there, and you start to see this pulsing here in between engine 1 and engine 4. That's the APU exhaust, which is gaseous hydrogen, which is probably not a good thing to spray on something that's burning. And so that actually caused the fire. You can see that visualizes the fire. And so then coincidentally, you see the engine start to wiggle there. Well, that was basically kind of like a flushing all your toilets at the same time test of the hydraulic system. And so what happened was that caused the pressure to sag, and that tripped their lower limits, and they shut down. And so this is another this is a camera that's looking you see the engines, but really what it's looking at here is it's looking at the boat tail to a great degree here, so which is the base heat shield, which is kind of in the middle of the engines here. It's covered with this reflective foil tape for the green run, because the stage is sitting in the stand for 8 minutes, which it normally wouldn't be, and it's also certainly wouldn't be sitting at sea level. And so this is a better view of what's going on. So you can start to see some areas of the engine blankets, and I'll go into that a little bit. They start to flake a little bit, and they're getting sucked into the exhaust plume, and the fire will be in the back right here, and now you start to see that pulsing on the right under the engine nozzles of the APU exhaust. Pardon me. And so, and then again, we'll see right at T plus 60 seconds, you'll start to see the first test, hydraulic limits tripped, shut down, and you see these sparklers that are coming in from the top right. Those are the hydrogen burn-off igniters, and those those are sort of the combined causes here of the fire plus the TPS configuration that they had. So the what this gave us a chance to look at was just basically to see more of what happened in the test. And so I think what I'll do here is um, I'll they've talked a lot about the hydraulic limits. Those are being those were adjusted, and so what happened with the fire was the engine blankets are thermal protection blankets.
We're looking
You
up
can
here,
see there,
folks.
right, and you can start to see some of that. They expected, well, it's a multi-layer insulation, but the outside is just plastic. It's a moisture barrier. You don't want to get rain or all of the other stuff that's going on outside, since it's an outdoor test stand, to get inside the engine section. So they expected this to burn away if the engines had fired for 8 minutes. I'm not sure that they expected to get that type of a fire situation, but what you have here is those sparklers, the hydrogen burn-off igniters. Some of them are pointed at the APU exhaust ports, and those are there's one for each of the hydraulic systems. Those ports are, you can see in these red boxes, are highlighted here. So a couple of things to point out here. So those, you can see there's 2 ports on the left, 2 ports on the right, and then you can see here where the engine blankets would be, and those are the engine power heads that are being protected along with the inside of the engine section. So the other one of the things that NASA noted in the blogs, that blog posts after the test, was that there was no, they didn't see any temperature spike or anything like that inside the engine section. And those blankets also seal the inside environment from the outside environment. And the engine compartment inside is also being purged with gaseous nitrogen. So there are vents to keep the pressure inside equalized, but they didn't see any effects of this fire. It's kind of a Delta IV situation where you probably have a very similar type of engine blanket around the RS-68 and the bow tail of the common booster core, except that you have a much larger ignition source because of the RS-68 start, the way that the RS-68 starts. And so you have the combination of the hydrogen burn-off igniters. A set of them are pointed under the engines because the engines start hydrogen rich, but then the APUs are running off the engine tap off, and so they are started on helium, and then when the engines come up, then they switch over to tap off hydrogen exhaust from the engines. So once you start exhausting hydrogen, you want to try and consume that so you don't get a pop, like a pop of a hydrogen gas bubble in the underneath the engines. So they intentionally pointed a set of those hydrogen burn-off igniters at that area. Well, in that picture of where you can see where those exhaust ports are, they're really close to a couple of the engine blankets. And so if you are throwing burning material onto plastic during the ignition sequence, and then you have this huge combustion area going on, it's just kind of a nice environment to set something on fire. You have, in addition to that, any of the little creases between where the blankets end and where the engine openings are, you'll have stuff like room temperature vulcanizer, which is like putty, but it's also flammable. Those types of things can catch fire. So, pardon me, one of the things that they're going to do in terms of changing things for the test. So the hydraulic limits, they adjusted those. They're going to re-aim those upper. You can see the sparklers up at the top there, and you can see the set at the bottom. They're going to re-aim those a little lower so that they're not spraying some of those sparks on the engine blankets. And they've also beefed up a little bit of the thermal protection system for the bow tail. So you see that silver foil on the bottom of the stage. That is only for green run. And so what they've done is they peeled back a little bit of that. Underneath that is cork with paint over it, but it's cork. So what they did is they obviously repaired the blankets there. They thickened the cork up in some sections, especially around those two engines where the fire was, and then they doubled up the foil tape. So they put another. So there's a one layer of foil tape on. They put a whole nother a layer of foil tape over on the base heat shield. So um, and so they're ready. So they had this issue with the liquid oxygen pre-valve after having an issue with the liquid hydrogen pre-valve. From what I understand, it's something with the clutch again. We're still trying to hear if there's a commonality issue there. But they repaired the clutch on that valve. They're basically getting into the pre-ops for the test. And so what they're trying to do is they had 10 major verification objectives they wanted to pick up in the test. They only got 3 of them fully. They got 6 partials and 1 they didn't get at all. So in the test, what they're going to do is the engines will start. They'll come up to 100%. The engines start at 6.6 at t minus 6.6 seconds. They come up to 100%. At t0, they go up to 109%. And then they'll do these 3 gimbal tests. You'll see those circular gimbal motions again at about a minute into the test. Then they're going to do this sinusoidal swiveling of the engines. Each engine has 2 actuators, a yaw actuator and a pitch actuator. They're actually going to exercise each one of them individually and do these back and forth motions, increasing in amplitude, and then they're going to combine the yaw and the pitch together, those motions. The engines in the test, they'll go up to 109. They'll throttle down to 95 during the first circular test. Then they'll come back up to 109 during this frequency response test where they're going back and forth. They'll be at 109%. That runs through about 4 minutes, 30 seconds. The engines will throttle down to 85% right before the end of the test. And then there will be another 25-second period of this circular motion right before they then straighten the engines out and shut down after about 8 minutes. At least that's what they're hoping. And then that would give them all 10 objectives. That would get the data for all 10 objectives. And then they also have some secondary test objectives with the thrust vector control system that they'll pick up in the frequency response test, which is in the middle of the firing. So I think right there, again, there's a lot of things going on right now. We just did a story on core stage 2. The core stage is made up of 5 major elements. Those are getting to the point where you can start to put them together. And so over the next probably about half of a year, we should start to see those come together. Forward skirt, which is the top part of the rocket, that's ready to be put together with the rest of the vehicle. That's actually been put down on this thing called the BAT. It's a barrel transportation tool. They're actually doing that to clear floor space. That's the liquid oxygen tank. That's in building 110. The circular opening at the bottom there, which is now pointing at you, that's the sump. They just finished installing that. They have to do that on the vertical where they drop a technician down to the bottom to do the internal mold line screws. So they moved it back over to horizontal, and now it's in final assembly. And the hydrogen tank just finished its primer, and you can see them moving it over here to next to the liquid oxygen tank, which you can see on the left there. They did this a couple of weeks ago, and so it's now getting ready to then they have to put on sensors and wire harnesses, and then it'll go in for its foam sprays. And then here you see the boat tail in the foreground. That's ready for stacking with the engine section, which is in the back. The engine section is critical path, and so there's still plenty of work to do on that. They're starting to put in the hydraulic system hardware There's 5 large sort of human-sized COPV composite overwrap pressure vessel helium bottles that go in there. Those are going to get ready to go in here. The next major thing here is this is from the first core stage, which is at Stennis right now, and this is what they'll be doing. The first stage assembly will be this is this 3-shot. So first the inner tank gets loaded into the cell, then you bring the liquid oxygen tank and you stack it on top of it, and then you bring the forward skirt in and put it on top, and then they'll start doing stuff like foam closeouts. Each of those has a flange. You can sort of see them sticking out of the top and the bottom here where they're still uncovered they don't have any foam on them. There's basically radial bolts around there, 360 bolts basically at 1 degree intervals all the way around to bolt those physically together. And then you've got all this, you got to connect wiring, you've got to connect tubing and all of that type of stuff. And so then once they're done with that, they'll pick that up, lower it down to horizontal, take it back over to the final assembly facility, and then they'll wait for the hydrogen tank. So the assembly sequence will be forward join, which is those 3 top pieces. Then they'll put the hydrogen tank on in the horizontal. They'll bring those 2 together to bring the top 4/5 of the rocket together. And then when the engine section finishes, they'll take it over to a stacking cell. They'll bolt the boat tail on the bottom, and then they'll bring that back over to final assembly, and then they have to turn it over from this vertical orientation. Now they'll turn it to horizontal, and they'll connect it to the hydrogen tank, and then they'll basically get ready to load the engines, and then they'll basically be getting ready to do the final testing, and it'll, in theory, be ready middle of next year. So I'm sure I've already gone on too long as it is. So hopefully, but that's I think we'll have time to talk about some other things. I'm sure if there are any questions too.
Yeah,
Well,
it's hard to, get a word in sometimes because it's the knowledge on SLS is so extensive, and this is why Philip's the expert, so we bring him
Yeah.
in. But we do have some questions, and we touched on it a little bit. So, I mean, the big thing we're looking at when the reason we're talking about this green run test is because they're ready to do it again, currently targeting next Thursday at the Stennis Space Center, I believe, right? Which is the 18th.
Right.
And so this is going to be that redo. And like you said, there's those 10 test objectives, 3 of which they only fully satisfied in the first test. So they're going to be redoing those. So I'm going to start bringing in some questions here. We've got a whole bunch of them coming in. We had one. What is this kind of threshold that they need to reach before you can call it a successful test? If let's say they get like 9 of the 10 test objectives, I mean, is there some room for them to say, maybe we can verify that last objective at Kennedy Space Center or something? Because the critical thing is, if this test doesn't completely, satisfy
Right.
what they need to get, and there's some schedule delay there, you're now looking at not only a delay from what we're thinking is February of 2022 for Artemis 1 launch. If you delay past that, you now have this solid booster issue that you're looking at. We'll talk about that in a second. But first and foremost, how much room do they have to play with what they need to get done at Stennis versus what they might be able to verify via other methods and make sure that it's ready to go for launch?
Well, so the first thing is, if they were to they're saying if they get to 4 minutes, T plus 4 minutes, which would be in the middle of one of the tests, that they would get the data for all 10 of their primary objectives.
Okay.
So if they were to for some reason cut off in that 4-minute range, I mean, it's an informal minimum is what I call it. But it would be somewhere in
It's
there.
not like
So
3 minutes and 59 seconds is
right.
like a
So
problem,
I
but
think
4 minutes is
if
magically okay.
we get to that sort of boundary, then and they stop there, then I'm sure that there's going to be the question: did you get the data you
Right.
needed? And that's pretty much that's kind of the big question that they're going to be asking after they run this test anyway. I'm not sure that they can do that. That there's any way for them to pick up some of these other objectives anywhere except in the test stand at Stennis. Well, and flight. But
Right,
the
right.
idea
Which
behind this
once
test
you're flying, you don't
is
get to get it. You don't get it back if it doesn't go
correct.
well.
There's
So
right. So yeah, I think as we were talking about this, I think we talked about this last summer. you can't stop at 4 minutes in flight.
Mhm.
I mean, if you do, you have big problems. So, yeah, the launch pad at Kennedy is not designed for an 8-minute test.
Right.
It's designed for the rocket to get up and leave when you start the engines, and so uh, that's one of the reasons why they decided not to just do a short test like they used to do with shuttles
Mhm.
when they were getting ready for their first flight. But in that case, they also had a propulsion test article. So they were doing these kinds of tests at Stennis before the first shuttle flight, for instance. And then in complement with that, then when you had an orbiter come online, then they would just do a quick test. And really all they're doing there is just testing workmanship of the orbiter. Okay, the
Mhm.
plumbing in the back end works. So here, this is one shot. This is really, they're doing these tests for the entire program. So they're not planning on doing this again after this course. The second core, they're gonna, once they're done with it, they're gonna put it on the barge and it's gonna go straight to Florida for
Right.
stacking.
And so, talking about the potential consequence, so we know they're trying to get like 4 minutes approximately is about what they need to get this data that they're looking for, probably.
Right.
If it's close to that, obviously the question will be, did you get all of it and work from there? Beyond that, you still want to aim for that full 8 minutes because that's the mission firing duration. If you get like 6 minutes, for example, I guess is it safe to say that whatever consequences of ending early at that point would just be a matter of whatever caused the shutdown, and whether it's a small thing that they know easily how to fix and doesn't require a retest, or oh, we actually found something at t plus 6 minutes that we need to test and re-verify, right? That would be
That's a good
purely
point.
of, yeah, it's a function of what exactly caused the problem.
Right, that's a good point. So, um, if it's a facility issue, so
Right.
this is a rebuilt facility, so I wouldn't expect necessarily to see some of the things that we've seen, where you have 40-year-old facility water pipes and cryogenic tanks and things like that. The facility did really well in the first test, and but if you were to have, for instance, again, if you were to lose the water deluge, they have to stop. So
Hmm.
even the
But
problem,
that's obviously not a problem
you
with the
could come up
rocket;
with
it's a
a you
problem
could
with your
come up
ground
with kind of a
equipment.
worst case scenario too. So I mean, if the water stopped at 2 minutes, they got to stop. So,
Right.
but yeah, there's still that point of, well, if you stopped at 6 minutes, what was the problem? If it turns out, again, if it turns out it was a limit thing, like if it turns out the same issue, not the same issue, but if it turned out that they had a conservative parameter somewhere else in the system, like for instance, the repressurization, you've got this gas that's going back into the top of the tanks as the engines empty the propellant out of them because they have to stay pressurized. If for some reason you tripped a limit like that, and you shut down at 6 minutes, they might look at that and say, we can figure out how to um, adjust for that during launch, and we'll just go ahead and refurbish and take it to Kennedy.
Right. And so let's talk about that because at Kennedy right now, the other components of sort of SLS's first stage, if you will, the two solid rocket boosters are now fully stacked. And I've got a super chat question here from Rough Riders. Thank you so much. Asking if the secondary run does not pass for whatever reason, and they know they won't make this year timeline, do they need to destack those boosters? So what we're referring to there is once the boosters get stacked, the seals have a 1 year life, like I don't know if warranty is the right word, but like lifespan before there's issues there. If this core stage has further delays getting to Kennedy and can't support a launch within the year of when they started stacking, which is right around that February of next year mark, um, what's the process for dealing with that? Is there guaranteed destack? Is there other work they could do to recertify the seals and make sure, yep, they're still good? Or what are their options there?
Well, I think probably what they would do, if you're talking about like a gross delay for whatever reason. So, like if you're talking about um, March 22, and if you're talking about March 22 versus if you're talking August 22,
Sure.
um, I think the 12-month limit is a lot like some of the criteria that we've seen, like in shuttle program, and I'm sure in other programs where you have this is a generic 12-month stack limit lifetime, where um, the idea would be after that 12 months, you probably destack and inspect the J leg in the insulate, in the field joints. That's the specific limit. What they're doing is they're doing a more specific analysis based on they took some additional data when they stacked the segments, and if I'm sure they're taking a look at it, because if you're talking about even February, you're already at, again, it
months.
depends, because they sort of stretched out the stacking timeline. But I think they started actually doing field joint stacking in December. So you would still be running up against this. So they would do a specific analysis on this, and that will give them some number larger than 12 months, but it might not, who knows how much that is.
Well,
And
yeah,
you
how
could still
much
go
longer,
over
right?
that. So like, let's say it was 15 months, then you could still go over that. And then at that point, you're going to reach some point where you're going to have to probably, this is something would like to ask about is what is it at the end? Is it a D-stack? Or what do you need to do there? But I think really where they are right now is they want to do this test. I mean, just like we were about 3 weeks ago, we were sitting here about this point where they found the pre-valve issue. I think really what they want to do is they want to get the test done and then see where they are. Because once they get the test done, they'll know what the condition the vehicle's in. Even with this fire that you saw in the engine blankets, those are just going to be replaced for flight anyway.
Right.
So the foil's going to come off. So the idea is, what they said was, they almost had no refurbishment to do of the stage, things like the foam, some of the other TPS. The engines still have their standard refurbishment, and so that'll be what drives. It's about a 30-day timeline. So after the test's over, they would like to be on the barge within 30 days, and then obviously you would get down to Kennedy. That would be like late April, early May would be. I'm sure they would take that at this point. But they'll once they've finished the test, it's gonna. I mean, even in January, you look and see where you are at this point, and see, okay, what shape is the vehicle in? What did we get all the data that we needed? And then they'll go through their process to decide whether they need, what they need to do going forward. And then, I mean, they'll at that point also have that data at Kennedy to look at. Okay, they got what they needed. It's coming here. Let's get ready to, get ready to go here. And maybe there will be things to tighten up their schedule down there once the core stage is there.
Gotcha. And so, got more questions here. First of all, super chat from Thomas Anfang. Thank you so much. Talking about this fire that we're seeing in this first hot fire. Question here from Dog Cross. It's sounding like you maybe suggest, or this question is asking, was the fire in this thermal protection system an artifact of its test environment? The fact that it was firing on a test stand at sea level versus up in flight. You're saying that contributed in a way?
Yes. I'm speculating to a certain degree because, again, we just got this video yesterday. I think if they'd shown this 2 or 3 days after the test in January, the next teleconference with the media, they would have got a lot of questions about this.
Right.
But yeah, you're at sea level. There was a slide basically of the Capu exhaust plume.
Sure.
If see if you can pull that up. This is what you'd be looking at. Again, you're not visualizing the exhaust from the engines, and you're not visualizing exhaust from the solid rocket boosters. But the idea is that the plume's going to expand, and also your oxygen content in the atmosphere is going to go down as you get up into the upper atmosphere. So it is a combination of you're at sea level, you have you're also static, so you're not moving. You have these You have the burn off igniters. So I think part of it is pointing the burn off. The things that they're changing are they're going to try and change the streams of the burn off igniters so that they're not spraying onto the blankets. But then you're going to have this hydrogen gas that's coming out, that's just gas, whereas like the engines are much more of an efficient combustion thing. They're turning the propellant into steam and water vapor and heat and thrust and energy, but you have this hydrogen gas that's in the area. But yeah, it's a combination of that, and then again the blankets will still have that moisture barrier, that plastic over them. So it is. I'm pretty sure. Well, they told us they expected that plastic to completely flake and completely burn away over 8 minutes of time. So we're only looking at a minute's worth of stuff. I think that the changes they made to the thermal protection system were. I think they're trying to avoid that's something like that fire, although I'm not sure that they would have stopped necessarily if it weren't for the limits, that they'd have stopped at 1 minute there. So it is a little bit of an artifact of the test configuration.
Gotcha. And so obviously not everything you see during these tests is indicative of an actual flight problem versus just something preventing you from verifying the rest of your data before you get to flight, which is kind of an
Right.
important distinction to be making there. Some more questions here. We got a whole bunch of them. Let's see. What is the situation with contracts for SLS cores beyond the two that we see so far? So we've got the one in status right now for Artemis 1. We were just talking about they're working on forward join for Artemis 2. What about beyond that? What's the status of the future SLS core stages?
They're still negotiating with Boeing. So what they've done is, this was in, I think, the last Government Accounting Office report. What they're doing is they're continuing to fund production, these things called undefinitized contract actions, and so what they've given authority to proceed on already is core stage 3. So not just they've funded procurement of the materials for core stage 3, production of core stage 3, and then the materials for core stage 4. And in fact, I saw some just plate stock at Michoud a couple of weeks ago, which is that goes to Michoud, apparently goes to Michoud first, and then goes out to the contractor for machining, and then then it goes to another contractor for I think they call it bump forming, to take it from flat plates to the curvature that you need for the barrels. So core stage 3, they are that engine section barrel, which is part of the structure. Pardon me. That's already welded. It's actually getting the ring that's welded to the top. They're finishing primer on that. The thrust structure will get there, I believe, in the summertime, and they're going to start finishing structural assembly. They put the engine section first in line because it's critical path and because it's so complicated. And so they're actually doing production of core stage 3, and they're clearing floor space at Michoud. And what they're going to do is that forward skirt that we saw. There's a integration jig, which is basically a bunch of tooling that it sits down on so that people can do the work on it. They're going to take that jig and they're going to move it over to the east side of the factory. So they're setting up so that they can work on all of the elements except for the engine section. They can work on 2 of them at a time. So 2 inner tanks, 2 forward skirts, 2 liquid oxygen tanks, 2 liquid hydrogen tanks, so that they're finishing one, they're getting ready to basically start finishing the next one, and you'll start into this production line. For the engine section, what they're talking about is 3. So they're actually talking about doing integration on 3 of them in sequence. So for instance, for core stage 3, that's like the next phase beyond structural assembly. So take the barrel, you lower the barrel over the thrust structure, then you've got about 2,000 bolts to bolt the thrust structure into the barrel. Then it goes into integration, which is all the wiring, all the orbital tube welding, all of the moving parts, the hydraulic systems, avionics, propellant lines, things like cork on the outside, and then the things that you hang all of that stuff off of. There's a bunch of brackets and shelves that go in there because you have to. All that wiring has to be um, clamped down in such a way that that it's not being pinched or you don't want to step on it either when you're working inside there. So you have this. They're going to try and split it up so that you have 3 engine sections in process at the same time, in terms of just integration. And if that's the case, and I need to follow up on this, that would in theory mean you could have the 4th one down the line getting ready to go into that queue in structural assembly. So they're at least getting ready. Boeing is at Michoud to do that, because it's obviously, and this is something that John Shannon, who's the head of Boeing's SLS, he was talking about this a couple of years ago. He's like, we just want to get a whole bunch of engine sections. We want to be processing a whole bunch of engine sections in parallel, so that we can get up to the one per year. So just again, for reference, from beginning to end, it takes about 4 years to build a particular core stage. But if you stagger the starts of the production such, then you can deliver one of them every year. So
Right.
you have 2 or 3 of them in process. I mean, you're delivering them every year to meet this initial flight rate that they wanted to do.
While we're sort of talking about core stages and their construction and everything, I I have a question for you, Philip. Actually,
Mhm.
so we see the same, rust orange colored spray on foam insulation on the outside of the core stage that gives it that distinct orange color, like the shuttle external tank had, and everything. But that's largely to prevent ice buildup on the outside of the vehicle. But with shuttle, you had a vehicle that had a thermal protection system mounted to the side of it that you needed to protect, that foam really went toward protecting. So with SLS being an inline rocket and other rockets launching with solid rocket boosters mounted to the side of them, but no thermal protection system to prevent ice, why a TPS for SLS? Why is it still needed? Couldn't they save a lot of weight and a lot of complexity by getting rid of that? Or what
Well, I
purpose is
think
it serving now?
it's I mean, I think the other example, obviously, of a hydrolock stage would be like the
Mm,
Delta IV. Um, you are insulating, so it serves the other couple of purposes that it serves is it does actually also serve as an aerodynamics. It serves as a skin heating thing during flight, and it also insulates. It's also basically to try and prevent or try and
All right, folks. Sorry about that. We got an audio hookup, but we're back. We do want to keep wrapping up. We were talking about SLS. We want to wrap up. We got a couple more questions about SLS Green Run to get through here. Sorry about that. So I want to actually extend one here to Chris because we got some questions about sort of obviously SLS's main role now is this Orion crew launch vehicle, and so let's see here. Where's this question? I just had it. Oh yeah, this question here about from Brendan. Thank you so much, asking or just saying awesome knowledge drop from Philip again. So thank you, Philip. I still think it's crazy that SLS will be qualified for human flight after a single flight of the rocket. So can you give us some sort of background on that? SLS is flying one uncrewed test flight, Artemis 1, and then going straight into a crewed test flight on Artemis 2. What's the
Mhm.
historical precedent for that?
That's about right, honestly. In the history of how we've done things before, in terms of, well, I mean, actually, you know what? I wanted to say that, and then I started thinking, well, wait a minute, like we don't really have a current example that's really an apples to apples comparison of this. So like the early Mercury missions here in the US, like the Redstone rocket had flown a few times before we put Alan Shepard on it. The Mercury Atlas had flown several times and had a dubious track record before we put humans on it. And while we put humans on it, although thankfully none of
Mhm.
the human flights had issues early on. I mean, the Titans went pretty quick, in terms of when, like, they were actually transitioned into human-rated vehicles. The Saturn V flew humans on its
Third.
3rd flight?
Yeah.
Yeah, the Saturn IB was flew humans early on in its career. The shuttle did it on the very first one.
Right.
I think the difference here and what might be creating a perception of, um favoritism maybe is that you are right. SLS is being built and designed specifically to be a crew and cargo vehicle for the lunar program, so it will transition to that role very, very quickly, whereas the Falcon 9 and the Atlas 5 are already existing vehicles that sort of got taken and said, okay, you already exist, you're a good safe rocket, let's put capsules on top of you. So it just kind of happened that the rockets that got chosen, aside from SLS for US crew missions, happened to already exist prior to their being chosen. That which again is more in line with what it has been in the past with the shuttle, the Saturn V, and SLS being the three,
Sort of
you know,
exceptions, right?
exceptions to that. Yeah, is taking existing stock and using it to your advantage.
Thank you. And then also one other super chat here from Chris. We got a lot of Chris's around here these days, saying a general reminder to chat. SpaceX had a heat protection failure on a recent Falcon 9 flight, losing the booster as a result. It doesn't just happen on SLS, so bringing
Thank
some
you.
correlations there.
No, that's one thing I wanted to mention before. I didn't know if that was gonna be our transition, but, that was one thing I wanted to mention was they talked about a thermal barrier, on one of the Merlin engines on, a Starlink mission where the booster failed during the landing, and that they had a burn through of that blanket, and that's a very similar thing to what you were seeing that was, those thermal cords and thermal areas on the base of the engines, those engine heat shields that we were seeing that were on fire on the SLS hot fire test. That's exactly the type of structure that we're talking about, or that they were talking about on the Falcon 9 that failed. So yes, it is not just SLS that has these issues.
Right.
Right. And I mean, as I was saying, I think any Delta IV and certainly any Delta IV Heavy launch now, the base heat shield's going to be on fire
Right.
during flight. So at least a
Well,
little bit.
Yeah, that's true.
you
The
bring up
Delta IV
Delta.
takes off on fire, and that's
And they're
normal.
Yeah.
Boeing. They're both Boeing vehicles. So, and this
Yeah.
is we got these shots from Aerojet
Yeah, I wanted
Rocketdyne,
to connect this because you
and
mentioned Delta
so
4 real quick.
yeah. So anyway, we've been asking about this because during the green run, there are still acceptance testing R68A engines for these last. Well, it wouldn't be the last four, but for the last couple of Delta IV Heavy flights before that vehicle's retired. And so those are acceptance tested in the B1 position of this stand right next door. And so they just did one last Tuesday. And so we've been bugging Stennis and Aerojet Rocketdyne, and they were nice enough to get these pictures. And I think they tweeted one of them out yesterday at least. And so, but this is probably, I would say, at least the third, if not maybe more, engine that's gone through there, rotated through there during during the year and change now that the cores have been at Stennis.
Right. Yeah, just pointing
That
this
is
out
very interesting
because
because at a glance. Oh, sorry. Go ahead, Thomas.
I was just gonna say, Stennis is busy enough. It's not just this Corsair thing. You've got Delta IV engines, the RS-68 being tested there. There's a bunch of commercial companies, launchers over there. Relativity Space is there. I'm sure there are others, but it's not just core stage testing. They do a lot of this stuff at Stennis. Anyway, go ahead, Chris.
Yeah, no, I was gonna say like this is one of those photos where like unless you really look at which engine is firing, you could mistake that for a picture of the core stage hot fire.
Right. Yeah.
But it's just that little flame that gives it away. Yeah, because I think this week when I saw that photo when they tweeted it out, I just kind of glanced right over it, thinking it was a hot fire photo,
Yeah.
just from an angle we hadn't seen before. Yeah,
Yeah. Well, the other thing, just looking at it to me, is that they have a pretty hellacious easterly wind going on
I
there
know,
to blow
right?
this plume that hard to the from your east is on the right, so it's blowing from east to west pretty hard. uh, so yeah.
So this is cool. So that is our update on SLS Green Run. Like we said, the next test fire attempt on Thursday, the 18th. NASA Space, hopefully, NASA Spaceflight. We'll of course have live coverage for that. For stay tuned. But wanted to give an update on that and talk about all those things that they're going to be looking at. Try to do something different from the first test and get that data so we can get towards an Artemis 1 launch, which of course is the big ticket item. But we are coming up at that point of the show where it's time to change topics and. I guess there's this other rocket that we usually talk about. Sometimes
Oh, should we do should we go halfway around the world first just to freak people out? No, I'm
ooh,
kidding.
we
That
can
would
go.
be mean.
We can do that.
You
No,
want to
we
do
can do.
that?
Well,
Yeah.
now you've said it, so I'm gonna have to do it. Really quick, we'll do a quick launch recap for the week. Let's do that. So,
Yes.
Chris, I'll let you do this. Just a brief recap, and you know what launches I'm gonna show, so I know where you know we're talking. But go
Yes.
ahead.
Yeah, so starting halfway around the world, China had two launches, including the return to flight of the Shenzheng 7A, which is pictured here. It was a very nice night launch from the Wenchang Satellite Center on Wenchang Island or on Hainan Island. And it was launching a mysterious satellite whose name was not revealed until after the successful liftoff to be Xi'an 9. Classified, don't know much about it, know its name, off it goes. But this was important because this was for the Shenzheng 7A rocket, this was its return to flight mission. So the 7A variant had flown once before, actually March of last year, March 16th of last year. And the third stage, which is added to the 7A variant over the 7 base variant, failed due to a low pressure indication shortly after staging. So this was a big moment of returning this vehicle to flight. This is part of China's new generation of launch vehicles that are getting away from the highly, highly toxic nitrogen tetroxide and unsymmetrical dimethylhydrazine used on their stages and going with more conventional propellants. The Shenzheng 7A and 7 variants utilize liquid oxygen and liquid hydrogen for their stages, as does the Shenzheng 5, which also launches from Wenchang as well. So this was big and a good performance from that rocket and a success. And then China followed that up last night with another secretive launch, this time using the Shenzheng 4C, launching from the Zhuquan Satellite Launch Center in Inner Mongolia. This one lofted 3 new Yaogan 31 naval observation satellites. Basically, China says they're used for experimental technology testing, but the orbits and the configurations that they go into and other ways that other nations have of monitoring what everyone is doing kind of reveals that these are naval intelligence satellites looking at enemy ships and trying to decode signals and everything. Which matches with the fact that this was a classified mission and we got no video of it officially from China. But yeah, so China had a good week, as did the Falcon 9, which launched the Starlink V1L20 mission from the Cape Canaveral Space Force Station in Florida. And Thomas, I want you to talk about this because you did an epic job tracking this. But what was it like watching it through a camera and not being able to like experience it with your own eyes, which you have to
Right. So
when you're the
sometimes,
camera operator?
right. So sometimes those of us who are out doing broadcasts of things, it is you experience it through the camera, right? Which is fine. It's a good time. So we thanks to our members' support, I should say that, thank you all because you're the one that enable us to keep improving our coverage. We have a new broadcast camera that we're like got some tricks up. You may notice like during lunch you can see me throwing an ND filter on it so we can get this clear view of the flames and not just like this blown out bright circle. I think we're going to tweak that a little bit. We're going to keep working, see what really looks best. But yeah, it was a crystal clear night, or I guess it was morning technically. It was like 3 a.m, and it was a beautiful launch though. And yeah, we got some gorgeous tracking here, and I kind of kept with the second stage as long as I could. When the entry burn happened, I like zoomed out and tried to get the entry burn, but it was like going behind some clouds, so that was hard to acquire. And then once that was done, there's no hope in like reacquiring the second stage. So maybe next time I'll just stick with the second stage. I want to track it all the way to orbit next time. That might be fun.
Right,
But
right.
yeah, yeah, it was a super awesome launch, kind of a standard Starlink mission, 60 satellites off to orbit, successful first stage of landing. So SpaceX back on their successful streak there, 2 in a row now, after their landing failure a couple missions ago. But yeah, again, that's kind of just been the norm this year at Cape Canaveral, Starlink after Starlink. And funny enough, we've got another one coming up in, pulls up calendar really quick, 13
15
hours.
hours, 13 hours.
Yeah,
There we go.
so I'll be back down
Oh
there
boy.
again to bring some more coverage of that. But yeah, it was a picture perfect Falcon 9 launch as well.
So no sleep for you guys.
Sleep is overrated. It's fine.
You
But
guys aren't old then.
so that's
And then
sort of a good.
yeah, and then I was gonna say, I guess just to sort of like go around with the other two major news events with Hubble and ULA and everything, that the Hubble Space Telescope is thankfully back in science mode. This is one where whenever there's a tweet that Hubble has gone into safe mode, like I feel like everyone's heart stops for a moment. And you just go, oh, please, oh, please, oh, please, oh, please, oh, please. This was a software issue that caused Hubble to go into safe mode, which is what telescopes and our satellites do when they go, something's wrong. So they put themselves to sleep and basically into hibernation so that they can't accidentally do something to further harm themselves. And then we go in and scientists go in and they figure out what's wrong and they slowly bring it back into operation. They were able to successfully resume science operations 2000 EST or Thursday night, which would have been 0100 early Friday morning UTC. But interestingly enough, during troubleshooting, getting it back into its pre-science state, they realized that the aperture door was failing to close on the primary motor. So they had to switch to the backup motor to get the aperture
Hmm.
door to respond. Aperture door is normally left open during science operations, but when it goes into safe mode and when it's doing various things in order to protect the optics and the equipment inside of it, that door is closed. So the telescope, if it accidentally aims itself at the sun, it doesn't fry its optics, but that door didn't close when commanded to. So they switched to the backup motor, and the backup motor will now be the primary motor for it. So Hubble showing its age
Mhm.
in orbit. It has been 12 years now since the last servicing mission went up to the telescope. So the fact that it is still going
What?
is somewhat amazing here. But yeah, back in science mode, but definitely showing its age.
And then
And
yeah, you
then
touched
we
on this
had
other bit
2
of
new
news really
contracts,
quick.
right,
Yeah.
Thomas? Yeah.
Yeah, so this is the next round of sort of national security launches. They kind of award them in batches. And of course, the two companies that are serving that program currently are United Launch Alliance and SpaceX. And so they both got 2 more launches. ULA will be launching 2 USSF missions, both on Vulcan from Cape Canaveral. And then SpaceX was awarded 2 Falcon 9 launches, one from Vandenberg and one from Cape Canaveral, one for the USSF and one for the National Reconnaissance Office. And this is kind of that standard. Nothing too surprising out of this, I don't think. Not really even that noteworthy, just more missions to add to both of those providers' launch manifests. So,
Hmm.
And so that kind of wraps up the sort of news of the week, and we're just going to get into our full-fledged shiny rocket update. I'm going to call it that from now on, the shiny rocket update,
Well,
because
if we had orange rocket update earlier, I think we
yeah,
should
I know
call
we
it
got to go to shiny
shiny.
rocket now, right? We got to all the big rockets is what the items of interest
We
are
got a
here.
whole fleet of shiny rockets, not just one.
The fleet's growing
We
daily, it
do, yeah.
seems.
Yeah,
Although at this
and we
point
got
they're
a
also
shiny
starting to.
booster coming up too.
I know. Although I would like to point out that as the shiny rocket fleet grows, they are also destroying some of that fleet every once in a while. So maybe the overall net gain is slowing down.
Test
But
articles.
that's true. That's
You're
true.
getting,
Got a point.
that's what they're for. They're for data.
You have to
Really?
maintain Starship equilibrium.
There you go. Got a super chat here from Dougal who says, "Yay for new cameras, keep them coming." Thank you so much. Appreciate the support, and that's what enables us to get new cameras and bring you better coverage and things. So thank you. But again, reiterating, if you have any questions about this, I know there's Starship questions, so I'm just gonna give it a couple seconds to let that queue start filling up because I know they're coming. But a very brief update before we just get into full-fledged Q&A. We're looking at the most recent daily video from Mary down in Boca Chica, working on Super Heavy Booster number 1, BN1, which is gotten its methane tank stacked recently, and the two big sections are now completely assembled, and the only thing left is to take both of those sections and stack them together. And they're currently in the high bay ready to do that. So I know we're all looking forward to that. I don't know if that'll happen like before or after SN11, Starship SN11 makes its test flight. There's been some talk about, are they going to stack them in the high bay? Are they going to roll them out in two pieces and stack them at the launch site? We've mentioned on previous streams, this booster will actually likely not be flight tested. We're expecting static fire tests and then using successive Super Heavies to get into their flight test program. Because again, this is the very first Super Heavy they ever flew. And keep in mind, there were a few Starship prototypes that never flew, and they were sort of ground test and manufacturing Pathfinder vehicles. And so that's something to be considered. But exciting news on Super Heavy BN1, and then of course Starship SN11 out to the launch site. Let me see. I guess I should get video of that instead of just rolling booster footage over and over again. But Starship
Oh my
SN11,
gosh, that's right.
yeah, that happened this week. Remember?
Oh my gosh, that's right. No, I'd forgotten, honestly, actually.
Just this week,
It moves so
SN11.
fast. Yeah.
Yeah, I know. Out to the launch site, rolling out to Pad B, the suborbital Pad B, excuse me, and getting ready for its test flight. They completed their cryogenic proof testing, so leak checks in that sense all came back appear to have gone well, and they're looking at a static fire test next. They did not get to it yesterday. It looks like they were trying to clear the pad, and then they never really got to a testing stance. Their next opportunity would be Monday during that road closure, and then that could set the stage for a flight as early as Tuesday. In the past, it's taken a day or so between static fire and flight, so obviously that's a very early, no earlier than target. But the big thing is that static fire, which could occur on Monday. And of course, we will have live coverage of all of this here on NASA Spaceflight. But as I get back to the question queue tab, I can see that the queue is starting to fill up, just like I thought. So let's see what we've got here. A question here from Steven. Where do you think SpaceX will land the first orbital Starship? Will they do a landing in the water? Might be dangerous re-entering such a large object over land while still unproven. So that is a fair question when we talk about the Starship orbital test flight, which could occur later this year. Where are predictions as to what that flight profile might look like, other than probably launching from Boca Chica, right? What beyond that?
Um, so this is where I will be immensely fascinated by what the FAA will go for, and where these new testing requirements and the streamlined testing processes that are due to take effect here on the 21st of March will come into play, because obviously they'll be in place for that first orbital flight. I think where they landed is going to come down to, is the FAA okay with them overflying portions of land during the entry process? This is not necessarily a deal breaker. Space shuttle missions have come in over land before, tracking over the continental US and Mexico and Central America. Dragon, Bob and Doug's mission was originally supposed to cross the Florida Peninsula during atmospheric reentry, heading for the Atlantic. Cargo Dragons will do the same. So operational vehicles reentering over land is not a problem. Where they'll go with the test flight, I don't know, because once you're orbital, your options for how you come back down are limited by your orbital trajectory. So they go out due east, let's say, from Boca Chica on their orbital flight, which would make the most sense. You're coming back over the Mexican mainland at that point. There is no if and or but about that. So if the FAA or Mexico is not okay with that and landing it back at Boca Chica, then you would have to explore an ocean landing, because there's no other way to get back to the landing sites that I will put a major caveat on this and say the landing sites that we know are available, because who knows, they could totally surprise us with something out on the West Coast. But if you don't want to come back
Right.
in over the mainland of the US, then you've got to land somewhere on the western seaboard of the United States. And there are no places where we know they are looking at for that type of an operation. So your other option would be Phobos and Deimos being
Mhm.
one of those being ready to go out and catch it whenever that first orbital attempt would be.
And you mentioned the West Coast because there's this NASA partnership that SpaceX won a while ago as far as in supporting Starship development that said something along the lines of capturing imagery or data of an orbital reentry of their Starship vehicle over the Pacific Ocean. It specified that. And
Yes.
so we all went, well, if you're coming back to like Boca Chica or something off the shore of Boca Chica, like Gulf of Mexico, reentry probably starts over the Pacific Ocean, but not. But like the main part that you would like want data from would probably be over Mexico by that point. So,
Right.
and we were talking about, well, maybe SpaceX has this facility in Vandenberg, which has a landing pad. Granted, it's a Falcon 9 landing pad, but it's a
Right.
landing pad. And we were thinking, like, is that maybe what they're looking at? And that would make sense because then you're not overflying land for any significant portion of that reentry. That's the final touchdown at Vandenberg. Is that a possibility?
I mean, you'd have to sacrifice the Starship, though, because you'd have no way to get it out of Vandenberg. I mean,
Oh, right. Like, it would sit on landing pad
I,
and then go, okay, now what? Because they don't have the
and then
roads to get it out of there.
which is why I'm hesitant to say it, right? And I mean, I know Vandenberg has a dock, but even getting it there would be a massive challenge if you did. But that's why I threw out the huge caveat: unless there's a
Right.
landing site we don't know about, if the FAA is not comfortable with it coming in over land, there's really no other choice but to land it somewhere in the ocean at that point.
I think it's worth it because a lot of people were talking about like, oh, if SN10 sticks to landing, are they going to refly it? What are they going to do? And we kind of talked about, well, they could do this non-destructive inspection, which would enable it to fly it again, or a
Right.
destructive inspection after flight. Which, if they're going to do that after the orbital flight anyway, they're going to rip it apart and get all the data they can. Well, it doesn't matter if you can chuck it out because you'll just tear it apart right there on the landing pad, right?
No, right. I mean, and that could be part of the calculus, right, for what you do, because there would be a lot of engineering data to gain from dissecting the first orbital vehicle
Hmm.
that's been through the entire thermal regime and the night day stress um on the steel. There we go. Almost said aluminum. Yeah, no, there would be a lot that you could gain from a destructive evaluation like that that wouldn't make as much sense on a suborbital flight. Yeah.
Right. All right, all right, we've gotten to the point where the question queue is now super full. All right, we're gonna try and get through some of these. Uh, a couple super chats. Wystrom, thank you so much. Kenneth with a super chat question. Hey, y'all, hundreds of ships per transfer window need many hundreds of launches. Will they build orbital facilities and fuel them between windows? Oh, I see what you're saying. Oh, yeah, so we're talking about
Ah,
distant future when we're sending, fleets of ships out to whatever transfer. I'm assuming Mars is the key target there. Um, Talking about kind of stage them in orbit ahead of time and refueling them, and then all departing Earth during the transfer window. I don't know. Any thoughts on that, guys?
that's honestly what makes the most sense to me, because you a want to remove as much risk as you can if you're talking about like large scale settlement efforts on the red planet. You're exactly right. Like we would need many more ships going, than what we've seen, like the sort of one at a time uh, go. So yeah, and I think a way to reduce part of that complexity and part of that uncertainty in your schedule is, because you can simply loft these starships up into orbit, and if they're carrying cargo, even if they're carrying people to an extent, you can leave them in orbit, loitering for a little bit, and refuel them so that the launch is already done. So all they have to do is at the appropriate moment in their orbit ignite their Raptor engines and perform the Transmars injection burn. Now, I don't think this is going to be like we've seen in sci-fi movie where they're all counting down together and
And they
hundreds
all
of them
go at
ignite
once.
and they all
But
go
that
at
would look
once.
so cool, Chris.
It would. It
You mean
really,
to
really
blow up
would.
the Death Star? You mean like that?
Yeah.
Yes, blow up the Death Star mission. Yes. I don't envision it being something like that, but maybe one or two go during the same day, but you end up with like a train of
Right.
them going to Mars at the same time. Because what's equally important is when they get to Mars, you also can't have 100 starships at a time and one or two control centers back on Earth trying to monitor all the data as all of these things come down right at the same time. And if they're all trying to land relatively close to one another in the same area, having them all trying to do that at the same time wouldn't be your best bet based on some of the larger numbers that we've seen, right? You want them to land so that each of them has a good visual understanding of what the landing terrain is and where the other starships are, instead of, oh, surprise, you're there, Steve.
Right. So, and of course, this is kind of distant future object. We're expecting
Right,
first couple transfer windows, there'll be one or two starships. We're not sending
right.
fleets of hundreds in 4 years, but that is something that they got to start thinking about if that's the goal of the program. So, good question there.
Exactly.
I actually want to talk about this on-orbit refueling thing, which is kind of part of that question too, because that's a huge part of their Artemis program involvement too. The Starship has this lunar landing variant that we should
Huh,
know within the next couple weeks.
and you
Is it
can see it
in?
making a photo
Oh
bomb,
yeah, that's the nose
over
cone.
the
Wait,
white
hold on.
tent. Yes,
Right
on the
here. No,
yes,
wait,
right.
go back.
Oh,
I'm
no.
not as good as DOS, guys. Hold on. There. That's the nose cone of the lunar landing kind of mock-up thing, whatever they're calling it these days. Anyway, maybe we'll get a
Moonship.
better shot of that in a later. Moonship, yes. So orbital refueling, that's going to be one of those things that they're going to want to demonstrate pretty early on because, and Philip, you can chime in on this moon landing timeline of 2024, allegedly, needs to be supported by one of these moon landers, and in order to make the Starship variant work, you need on-orbit refueling to be operational. They want to demonstrate that before moving into an actual landing attempt. So um, Starship testing is obviously something that the Artemis program is keeping a close eye on. What kind of timeline do you think we might be looking at for when Starship needs to not just make an orbital demonstration, but make an on-orbit refueling demonstration if SpaceX wants to be on pace to support a moon landing alongside a crew launch from an SLS vehicle and that architecture?
Well, I mean, I think SpaceX has demonstrated a fairly high flight and test rate. So I mean, I guess I would hesitate to sort of set a deadline on it. I would think, maybe you're talking about um, how many opportunities they would set up ahead of a lunar landing attempt to do those different demonstrations. But I would expect, there to be, quite a bit of testing and ahead of that. It just depends on when they get their orbital, their first orbital demos. And I think, again, I think the way that their testing philosophy goes, you should see an acceleration and progress as they start hitting these milestones and hitting these um, um, once they start landing, they do orbital tests. That would be my assumption, is that you would start to see things accelerate in terms of hitting milestones more, not just every month, maybe every couple of weeks, every week. Um, and so I think, I guess the other thing you wonder about with SpaceX is SpaceX has has its own funding stream independent of NASA. And so, my question is how much of a hindrance is the clipping NASA's funding going to be on what they're doing? I certainly don't see any slowdown in what they're doing. So I wouldn't assume that there's some sort of a cause and effect there, but I just don't know what it is. So, maybe they go to the moon on their own schedule. So, then I wouldn't be surprised if if they're ready to go, they might not wait for NASA.
Yeah. I think to the core of the question, I wouldn't answer it from a date perspective. I would answer it instead from a flight perspective. I think we'll see 2 or 3 orbital flights, and then they will start with orbital refueling. And here's my thought process on that. Um, they can still be working with that final flip and burn landing and figuring out the nuances of that while testing on orbit refueling. Because if the launch phase of getting them in orbit works, you can then trade off, okay, well, there's a huge technical complexity potentially with on orbit refueling that we want to do several times to make sure we've got it down, right? Because it has never been done on the scale that we are talking about with Starship. I mean, like, we are talking about on orbit refueling of little boxes outside the
Yeah, it's a
International
little
Space
different.
Station. Starship's like, hold my beer, you know, on that. So there are things that they need to work out. And what we have seen them do is go for the more complex things, right? Start with the complex, because the smaller things that are just fine tuning and tweaking based on the ultimate design of the vehicle, that can come later. And I'm not saying that landing successfully is a fine tuned tweak. It's a fairly significant
Right.
part of the design, but you don't have to have perfected the landing structure of this thing to then move on to orbital refueling. So I think once they get a couple of them successfully into orbit, I think we will start seeing orbital refueling follow very, very quickly thereafter.
Gotcha. I know that's something that we're all going to be keeping an eye on. So let's talk a bit about this test program that's going on, because that's where most of these questions are now coming from in order to support getting towards our orbital demo and on-orbit refueling demo. First, you got to land the thing from 10 kilometers, all right? So let's talk about that.
Yes.
A super chat here from Gary, who asks, any updates on why the 3 SN10 legs failed to deploy? So to clarify this, we don't think they failed to deploy per se. The big thing that Elon was talking about on Twitter after the test was this thrust issue on one of the Raptor engines, which actually I can pull up a tweet because he talked about this in a little more detail. Basically, they had some likely helium ingestion into one of the Raptor engines, so its thrust was not where it was supposed to be. That's not Elon Musk, that's Joe Bernard. This is the tweet in response to Austin Bernard. I called him Joe Bernard. Austin Bernard. Sorry, Austin. But Elon's saying that it was a low thrust on one of the engines due to partial helium ingestion from the fuel header tank. So we know that's actually a continuation of an issue that they had earlier, talking about failing to pressurize that header tank properly. So they moved from autogeneous pressurization to helium ingestion pressurization, which may have contributed to this issue. So yeah, the legs failed to deploy, but it's because this engine was not producing the thrust that it needed to. So it was, the acceleration loads were completely different. And so regardless of what the legs were doing, this landing was going to fail because of this thrust issue. And in fact, the thrust issue might have caused the landing legs to not lock in place properly because the vehicle was going at a different speed than it was supposed to. So that's kind of our biggest update, is actually from Elon on that thrust issue.
Because one of the way, and I think it's worth pausing for a moment to talk about the legs, because one of the way the legs work is they utilize that deceleration
Hmm.
of the vehicle, right, and that downward pull, so that when they're released, they boom, you slam down and lock down into place. But if you're not decelerating at the correct rate, you're not oriented correctly, you're going too fast, right? You could get airflow that prevents them from locking into place. But like Thomas said, they were going to get crushed anyway based on the rate that the vehicle was falling toward the ground at that point. Granted, a controlled fall and more successful than the others, but they still would have crumpled upon landing.
And then this is kind of a follow-up, because our own managing editor, Chris Bergen, noting that this is connected to this problem on SN8, and Elon kind of putting on that, actually kind of taking personal responsibility for approving it, which he tends to do on these sort of test flights where the outcome isn't less than perfect. But yeah, so they're still working on that issue. Of course, it's a test program. They're going to learn from it and figure out kind of what the long-term solution to that is. And it'll be interesting to see. I also want to point out, before we get back to the question queue, this other long-term solution that Elon threw out on Twitter. I wonder if either of you know which one I'm talking about before I bring it up. Because we
Well, I feel
can't
like
just
it's
not
cheating on
address,
our back end.
we can't really just not talk about this tweet, okay? So Elon mentioned a while ago that a way to potentially design out the mass loss of having landing legs on the Super Heavy booster is to use ground equipment to catch the booster. Just let it come down and kind of hover, and then have a structure on the launch tower grab the vehicle and secure it that way, which is ridiculous enough as it is. But now he's saying that they might just do that with the ship, which would negate the need for landing legs on the upper stage on the Starship vehicle. And I'm
Except,
just gonna make a couple points here, and I'm sure Chris has more too, and Philip. There are no launch towers on the moon and Mars, so if you're
correct.
gonna land there, you need landing legs regardless. If you're designing landing legs for those places, you have the landing legs, you might as well just put them on all of the starships and not design this launch tower contraption thing. And 3, this is supposed to be a crew vehicle at one point and conducting landings with crew on board, and now you're saying that you want to do this launch tower landing thing with a vehicle that has crew on board, which my first reaction is not positive for. What are you guys' thoughts on this sort of suggestion?
So I admit I don't personally have I didn't personally have the reaction of oh, this will carry people and there's going to be a tower right next to where it's coming down. I actually didn't have a problem with that because I think software and controllability of vehicles is really to the point where you could, if you, I mean, if you really put the work into it, you could figure out how to make that reliable. But no, mine
You
was the first
could.
one you mentioned, Thomas. I was like, that's great, except when you get to Mars and when you
Right.
get to the moon.
I think that's my
That to
biggest
me is
point.
the biggest problem. And you know, uh, to me, I guess the only thing that I would think of that a tower on a landing would be a problem with is, one of the things that was kind of revolutionary about this design is that if it's coming into land, it doesn't have to worry about a tower, and it's got a landing pad that's, X number of meters by X number of meters. That gives you quite a bit of wiggle room when you're dealing with lower atmospheric winds and storms that you might be trying to come down and land in. Because what we've talked about with point to point is, if it's 45 minutes anywhere on the planet, you could launch from Sydney, Australia toward Orlando, Florida, and it's bright and sunny with not a cloud in the sky in Florida. And you get here 45 minutes later and there's a tornado warned thunderstorm you're coming down into, and, once you launch, you can't stop. So, but a tower means that landing has to be incredibly precise and would
Mhm.
be more, we'd run into more problems of weather related delays for
Yeah.
things, whereas your weather is already good to lift off.
Mhm.
So simply turning your booster around and flying it back for a landing 7 minutes later, your weather's still going to be good
Right.
for something like that. Makes sense in that regard. I don't know. I'm really dubious about that one, but we'll
Yeah.
see.
I think I agree, and I think that it's a little early to be seeing what the end result of that program might be. I think we'll wait and see where the actual operational architecture ends up. But I'm just gonna. And when this tweet came out, I also retweeted. I just said, for the record, I'm on the side of this seems like a bad idea, and I'm just gonna put that self on the record there. But I've also learned to stop betting against SpaceX, so I guess we'll see. But let's move on. We got some more questions here. Let's see. Dan with Super Chat question: why only do a static fire with BN1 and not do a test flight? Also, do you think they will do suborbital flight of Starship on booster before orbital? All right, so 2 questions here. First off, there's a lot of data you can get from a static fire, and since this will be the first ever, I should probably unpause the video first. Much better.
Oh, I thought it was just a
I was like,
picture.
why isn't that moving? So you can get a lot of data from sort of a hot fire, like a static fire test. And this is the very first super heavy booster they're building. They might have already learned through their manufacturing process and building the booster, like, oh, we have to actually change this thing before we get to a vehicle that we'd be comfortable flying. And so we can get some ground testing out of this vehicle, but let's just build BN2 and make that the first one that flies. Which is kind of what happened with the Starship program. As they built the first Starships, which were like Starship Mark 1 was allegedly going to fly to 20 kilometers, according to Elon Musk. Remember when that happened? So when they build the first kind of vehicles, the teams will realize, oh, actually, we learned some things just from building the vehicle, and so it's better off to just build better ones before you actually get into test flights. So I would guess that that's actually the reason that we're kind of expecting a ground test with BN1 now instead. Obviously, planes are fluid in Boca Chica, so we'll stay tuned. Hopefully, we'll find out pretty soon, though, as BN1 is nearing completion. What do you guys think about the second part of doing a suborbital flight of a full stack, Starship and Super Heavy, but neither of them going all the way to orbit?
I struggle with what that would give you,
Right.
and hear me out, because if you mount it on top of the Super Heavy booster, right? And we know from the Dear Moon presentation, Super Heavy with a full complement of Raptors launching a fully fueled Starship would burn for about 2 minutes 50 seconds before shutting down and separating to fly itself back. If it burns for that amount of time or slightly longer, let's say a couple of Raptors shut down on the way, but you get to the point where you're staging and you stage correctly, and all 6 of your Raptors light on Starship, what do you gain by then purposefully doing a suborbital flight versus an orbital flight? And I think that's where the line sort of becomes like, it's not impossible to launch Super Heavy on a high altitude flight of its own without without Starship acting as the
Hmm.
nose cone, but it is really limiting. So once you put Starship on it, if your orbital pad is good and ready, go for it.
Right. What do you think we're gonna be expecting from that orbital test? Like, what's the thing they're gonna demonstrate? Because we're talking about test objectives here, and we're not sure a suborbital flight gets you much. When you get to orbit, what's the thing they're getting from that they're not getting from suborbital test flights?
Yeah. So this is the test of the entire flight envelope, right? So not so on the suborbital flights that we've seen so far, right? We've seen the repetition of the vehicle's ability to orient itself into the correct belly flop position, control itself very stably for that free fall, and we're seeing them working through the issues of reigniting the Raptors for the flip and burn landing. The biggest things that have not been tested are how do the propellant tanks that will still have liquid oxygen and liquid methane inside of them, how are they at thermal conditioning based on the current thermal properties and thermal protection system around the vehicle? Once it's in space, you have to maintain the temperature of that propellant because you need it for the deorbit burn and coming back, right, in the header tanks to land. You also very crucially have to test your full thermal protection system's ability to protect you against the 2,500 to 3,000 degree Fahrenheit temperatures of an Earth. Sorry, 2,500 to 3,000 Celsius, I believe that is. Um, Temperature return that the plasma that starts to form around the vehicle um, can reach. You need to make sure that your thermal protection system is working the way it's supposed to. You need to make sure thermal protection system is not stripping off as you go supersonic during flight, as you're transitioning between the different realms during atmospheric entry. There's a lot that an orbital test gets you. And mainly, the vehicle's ability to keep, to function for a prolonged period of time in orbit and the various thermal stresses and cycles that it goes through as it swings from, the negative hundreds below 0 centigrade up to the positive hundreds of degrees centigrade, just from going from orbital day to orbital night every 45 minutes can do. So lots to test, and lots that data can give you that a suborbital flight wouldn't.
Cool. All right, I'm going to bring in some more questions here. I got a super chat here from Cal saying, "Is it possible to create a bladder type system for the header tanks to maintain pressure yet avoid gas contamination?" So talking about a tank that's not rigid, a tank that can be flexible, and thus you don't have those gas bubbles forming, I think is the purpose of the question. Is there like, are there, do you guys know of space vehicles that might have employed something like that? Uh,
I can't think of
Not off the top of my
anything
head.
of of that scale for sure. Um,
I
but
mean,
I mean,
No.
also, what anything that like a non-rigid structure that can handle cryogenic temperatures.
right.
Um, I think that's. I can't think of
I
anything.
can't. No.
I don't think we have precedent to say that would be a good idea. That doesn't mean it's not a good idea. I see the purpose of the
It would need to
question,
be
but
tested. Is
yeah,
that
it would
you'd
need to
have
be
to test
tested.
something like that would be interesting.
Cryogenic
Yeah.
temperatures is kind of a changer for a lot of the design considerations, so that might rule that out. But a fair point. Maybe we'll come back to that and see if we can figure something out. But let's see, more questions here. Super chat: how does SpaceX plan to secure landed or potentially damaged starships going forward? Do they have robotic arms to detank the vessel beforehand in uncertain scenarios, or would they rather use the FTS? Well,
Not the latter.
yeah, well, I'm going to assume that would be in the case of an uncrewed starship, but so securing like less than nominal landed starship vehicles if a leg collapses or something like that. I don't know.
Yeah.
Octograbber starship version? I don't know. Is that a thing?
I mean, I think ultimately what the system would be designed for is to sort of handle a one or two leg out at landing scenario. Specifically for the reason of like, yeah, you're going to have not just pretty expensive equipment coming back on these things every once in a while, or like Mars getting to its destination. You're going to have people on board it at some point. So I imagine the goal is to for the vehicle to be able to handle a multi-leg out sort of situation
Hmm,
like that for extra redundancy. Aside from that, they would probably, I mean, these things will eventually be landing near their relaunch sites. So the crane to pick it up would already be there to pick it up and restack it if it's an Earth, if it's landing somewhere on Earth. Um, but in terms of how would they get the propellant out of it, if they were really worried about something like that, or moving it in that condition, if it wasn't leaking any propellant, they could simply open up the vent and pressurization valves and just let the oxygen and methane boil off. It would take a while, but they could do it and just let the tanks inert themselves before moving the vehicle if they had to.
gotcha. And here's a question, super chat here from Astro6. Thank you again, everyone, for the super chat so much. What if catching the booster and Starship is only a temporary fix until they work out the leg issues that they obviously have? And if they are recommending catching, then they must know it could work. Well, okay, so Elon has mentioned the catching idea as sort of a possible idea. So I'm not sure he's claiming they've figured it out and that they know it would work. I think it's like design they're considering, and it's still under evaluation. But
I think
yeah.
everything with SpaceX is more to me in the category of, oh, it's possible. The only question is, are like, will the hardware and the software marry to make it a reality, right? Because we have seen things recently in the space program where we're like, yeah, no, we've wanted to do this. We've known how to do it
Mhm.
for years, but literally the technology or the software just wasn't there to make it possible until eventually it was, and then we were able to do it. So I don't know. I think that's more along the lines of where it is for me on the will they catch it versus the in terms of catching the boosters. Um,
Sure. All right, so let's see what other questions we've got here. A question here from Ross. When do you think SpaceX will transition from suborbital Starship test flights that return to the launch site to flights that pitch downrange and land on a sea platform, talking about Phobos or Deimos? Um, we know that Elon mentioned they want at least one of them in partial operations or like limited operations by the end of the year. Could that be in support of suborbital test flights, or is that something we're talking about for orbital test flights? What kind of role when might they start playing into the equation?
so yeah, I think once you get to the orbital flights, that's where what we were talking about earlier, the what the FAA is comfortable with of how they re-enter and where they're re-entering over in their initial test campaign. If the FAA doesn't get comfortable with them being on land, then yeah, one of Phobos or Deimos would have to be ready to catch the Starship. You know, provide a landing platform somewhere in the Gulf of Mexico or the Atlantic or you know, I'm assuming it would be the Gulf of Mexico based on where the production site is. But yeah, one of them would have to be ready for that first orbital attempt if the FAA says no, you can't come back over Mexico to land at Boca.
Gotcha. And then we're coming up on the end of the show. Get one more question here at least. Here's a question. Can Starship do a round trip to and from Mars without in situ resource utilization? So that referring to the process of refueling Starship on the surface of Mars using resources on Mars. Is Starship capable of, if they do on-orbit refueling in low Earth orbit, so they start with full tanks in Earth orbit, then do the trans-Mars injection, land on Mars, have X amount of propellant left. Is that enough to get back to Earth from Mars? Do we know?
I do not. Um,
Off the
I,
top of my
I
head, I
honestly do
would
not. And
guess no.
yeah, I mean, I could cheat and I could say yes because you could always design a trajectory where you would intercept Mars but free return yourself back to Earth. Um,
Not land on Mars. That's true. That's going to
right.
Mars. That's for sure.
Right, or, like, getting yourself to Mars, slowing down and sort of throwing your cargo into orbit, turning around and coming back without actually landing if you were doing something like that, like if they were deploying
Hmm.
satellites into orbit of Mars, right, for a communication network, or something, but yeah, I don't know because I think the answer honestly comes down to how heavy is the payload that Starship is trying to inject into a Mars orbit, or inject out to Mars, and that based on the delta V that you need to impart to change your velocity to do that, gives you how much propellant is left in your tanks at the end of that. But I don't know the actual answer. Just in general, yeah.
All right, one last super chat question here asking about the reentry cross range abilities of Starship. Do we know what that might look like? And and we'll end on this because it's a shuttle question too. Will they use reinforced carbon-carbon panels in the fin leading edges like shuttle did? So we got two big
Yes.
shuttle experts in the room. Any thoughts?
So the answer to both of them is, for the first one, it is, we don't know. They have not said. It is not as much as the shuttle because the shuttle had those gigantic delta wings that could just do an incredible. It was something like 1,500-mile cross range capability that the shuttle orbiters had. Starship does not have that. They are made to pinpoint a much more specific location for when they're coming down to land. So don't know what the cross range capability is, but there would obviously have to be some because orbits very rarely perfectly align
Right.
with your landing site. You're normally having to cross range some to get to where you want to be. The answer for the other one is no. It will not use RCC panels like the shuttles did. Kind of what you see is what you get, except for one side of them will be covered with the black thermal protection tiles, and maybe that's what will be used on the sides. But Starship is made of a very different material. It will re-enter differently than the space shuttle did, and and its surfaces are different than the shuttle is, and all of that sort of plays into how hot do specific areas get and what material do we need to thermally protect the vehicle. Because one thing that Starship is going for that shuttle did not is this particular version of steel that they're using. And Thomas helped me out with the name, but basically it has such a high
304L is
melt.
the current alloy.
304L, there we go. Is basically it has such a high melting point. You could almost do the entire thing without a heat shield, but not quite. Versus the shuttle, which is like you lost one tile in one very specific area, and as we saw with Columbia, with the leading edge of the RCC panels, you lose one, and that was it. And for Starship, there's a little more margin, a lot more margin there in terms of its thermal properties.
Philip, anything to add as far as shuttle heritage and Starship cross range?
I would have more questions about the Starship stuff. I could be wrong, but I believe that again, because of the shape of the orbiter, the reason that you had the carbon panels where they were on the nose cap and on the wing leading edges is because I that's kind of I think where the interplay with the different shock
Mhm.
waves coming off the orbiter during the hypersonic descent, that's where you obviously where you got the highest temperatures, but I think it was because of that kind of interplay of the different shocks and the plasma. And so, I mean, one of the questions I would have in, if you're kind of doing a side by side comparison is sort of a altitude and velocity plot. If, is Starship, how, how fast is Starship entering and at what particular altitude and things like dynamic pressure, curves.
And its angle of attack.
If you're able to decelerate, and maybe that also factors into cross ranges, you might be able to do some sort of a propulsive cross range capability if there's enough propellant left over. they might be able to increase their work cross range propulsively.
Oh, that's a good point because you can because if you've got the propellant to use, part of your deorbit burn can also be changing your
Right.
inclination, which would change your ground track. So you could do that more pinpoint alignment with your landing facility while you're doing the deorbit burn. Yeah.
Hmm. Yeah.
So there we
So
go. Yeah. Thank you so much, guys, and I think that's gonna wrap up our coverage today. Thank you so much. Want to introduce the people who are joining us today. First and foremost, Chris Gebhardt. Oh no, see, I did it backwards again. The camera's mirrored, guys. Chris Gebhardt, Assistant
yep.
Managing Editor of NASA Spaceflight. Thank you so much for joining us.
My pleasure as always. It was fun to talk about Orange Rocket and Shiny Rocket today.
There you go. And then on the other side, Mr. Philip Sloss, our NASA Center's editor at NASA Spaceflight and resident SLS expert. Philip, thank you so much for being on today.
Thanks for having me again. That was cool.
I want to give a huge thank you
And
to
Philip, you'll
everyone.
be with us
Oh,
at the green run, right? Oh, sorry,
yes.
Thomas. Yeah.
Yeah.
Yeah, of course, Philip. We'll be
We're
back next
certainly
week, right?
hoping so. We're working on it.
Absolutely. So live coverage next week of Orange Rocket on Thursday with the SLS Green Run Hot Fire #2, and then Shiny Rocket making hopefully a static fire on Monday and a launch attempt maybe the next day or sometime early next week. So we will be bringing coverage of all of that. So thank you so much. We could not do that coverage without the support of all of the Super Chat members, or Super Chats and YouTube members, excuse me. So I want to give a big thank you to our launch directors and flight engineers. We keep having to make the text on this screen smaller, which is just such an awesome problem to have. So thank you so much to everyone who supports the channel and allows us to do what we do. But that is going to do it for this week's episode of NASA Spaceflight Live. Thank you so much for tuning in, asking questions. If we have a question that we did not, or if you have a question that we did not actually get to during the show, please follow us on social media. You can follow the main account at NASA Spaceflight, or a couple of us have our own social medias. You can see them at the bottom of the screen. So if you want to send questions our way over there, we'd be happy to extend our Q&A and get you some answers and talk about things over there as well. But that's going to do it for today's episode. My name is Thomas Burghardt for NASA Spaceflight. Thank you so much for watching, and we'll see you next time.
Propulsion continues to be normal.
Our chamber pressure looks good. Doubling up. Roger, roll, Atlantic.
Water towers fly!
Flight outside of speed off.
Yikes. You bet. Sure. We don't need any more of these.